This is a presentation about the Cipher encryption. Imagine a scenario where you're in a cafe and you're working on a very sensitive project. You leave the cafe and a friend comes up to you before you're done packing up. He goes on and on about his routine on Retro Bowl before he leaves. Eventually you leave, but halfway to your apartment, you realize you forgot your laptop at the cafe. You go back to the cafe only to find your laptop is missing. You immediately think about the sensitive project on that laptop, but you feel relief that you have BitLocker. Then you realize that it didn't open up or even stop you while logging in earlier that morning. So you start panicking. But it's okay, you have Cipher encryption, and you have the USB stick. Regular encryption works like this. There are files and an encryption key. A program scrambles the contents of the files using the key. The only way to decrypt the contents of those files is with the same key. These programs normally store the key on the same hard drive as the encrypted files, which means that if someone gets access to the hard drive, they can decrypt the files. Cipher encryption puts a physical barrier between your files and the encryption key by storing the key on a USB stick. As long as the USB is separated from the laptop, the thief cannot access your data, and your project is safe. Test-driven development was a key methodology used to construct the Cipher encryption. After the requirements were established, a unit test project was created. Some of the tests in the project included encrypting a file using a known key, decrypting a file using a known key, and generating a random encryption key. Once the tests were created, each feature was implemented and refined until the test passed. Materials included a development computer running Windows 10, a USB drive given by Mr. Schwick, a Visual Studio, a free community edition, Inuit Library for unit tests, a free open-source library. A problem discovered during the construction of the prototype dealt with UTF-8 encoding. The UTF-8 standard uses variable length characters, which did not work with the initial encryption and decryption logic used in the program. To fix this issue, the logic was changed to encrypt and decrypt the bytes within a file, rather than encrypting or decrypting individual characters. Unit tests and user tests were used as testing methods for the Cipher encryption prototype. Unit tests are tests performed by the computer. They are constructed by writing code that calls the methods in the Cipher encryption and use assertions to prove that the methods behave as expected. The Cipher encryption project uses NUIT as a testing library to run these unit tests. User tests are performed by a user executing the program. These tests check the program at a high level and prove the individual methods work together. The user would run the program using pre-specified test files. The user would check that the program ran without errors, made the contents of the encrypted files unreadable, and that the decrypted files exactly matched the original test file. For user tests, the test files were chosen so that the user could easily identify the function had worked. A small file with a variety of characters and punctuation was used from an article on Wikipedia. A very large file was also created by combining passages from many different articles on Wikipedia. These files proved that the program worked as expected, and no issues arose when the file size increased to at least 500 megabytes. Unit tests were created to test things that the user cannot see, and to give confidence to the programmer when making changes or integrating new features. These tests also use files and sources that were specifically designed to catch edge cases or corner cases not likely to be seen by a user. A redesign was necessary when it was discovered that some UTF-8 test sequences did not correctly encode or decode. This was caused by the way the encryption-decryption logic was constructed, but it was discovered through testing. The solution was to switch from encrypting and decrypting the characters within a file's contents to encrypting and decrypting the individual bytes in a file. The prototype exceeded expectations for it outlined the requirements. Namely, it was initially decided that the program should encrypt or decrypt a file of 500 megabytes in no more than 60 seconds. The prototype was able to encrypt a 500 megabyte file in about 4 seconds, based on the user's test performed. In this way, the prototype works well and exceeded initial expectations. Here's an example of the Cipher encryption, creating a encryption key on a USB drive, encrypting a file, and decrypting that same file. Right now, I'm showing off the encrypted version of the file. And now I'm typing in the file path for the encrypted file for the program to decrypt it. And then you gotta type in the USB volume label to find the key, and now is unencrypted. This was a for loop article found on Wikipedia. There are definitely areas where the cipher encryption program could be improved. One way the program could be improved is to allow users to encrypt and decrypt files of any type rather than just .txt files. Another improvement that could be made, given more time, would be to add user-friendly GUI, a graphical user interface. This would make the program friendlier for users that are not used to command line applications. In conclusion, the Cipher encryption program works very well and exceeded the initial expectations set for it. It provides value for users that need to encrypt specific files and to assure that those files cannot be accessed, even if the machine itself is compromised. It fills a niche that is currently unfilled in the market of encryption and decryption software, giving users more control over what files they encrypt and how the encryption keys are stored. It could be improved and extended with more work, but it has met all of the initial requirements set for it, and passed all the tests which were established in the initial design. Some acknowledgements are my brother Ben Godwin, who helped with the programming of the prototype, and my mom Anita Berger, who helped with setting up the tests and visualizing the whole scope of the project and help shaping how this program works. Now, there are quite a bit of research involved in this project, so to the right is a whole list of sources and all the URLs to them.